Welcome everyone. Today we are going to discuss about complexity of algorithms. Now what do we mean by complexity? Suppose we are having one algorithm. Now obviously we would like to know how the algorithm is performing. What is the performance of the algorithm? So in order to find out the performance of the algorithm, we need this complexity. We need to find out the complexity of algorithm. So basically complexity of algorithm is used to know how good a particular algorithm performs. It is the function f of n which gives the running time and or the storage space requirements of the algorithm in terms of the size n of the input data. So complexity is of two types. One is time complexity and another one is storage or space complexity. So what do you mean by time complexity? The time is measured by counting the number of key operations. So how many key operations you have done in order to complete the algorithm, that gives the time complexity. And what we mean by space complexity, it means the amount of space that is required for storage purpose, that gives the space complexity. So whatever algorithms we'll be learning in the coming videos, we will try to find out the complexity of those algorithms and we will concentrate on finding the time complexity. We are interested in finding time complexity, that is the number of key operations. Okay. Now how do you represent the complexity of algorithms? So the way, how do you measure distance? By use of kilometers, meters, like that. In the same way, to represent complexity of algorithms, we are having some notations. There are different notations available. So among these are the notations that we need to know: big O notation, omega notation, theta, and little o notation. So out of all these notations, we will be using the big O notations to represent the complexity of any algorithm. So whatever algorithm we'll be learning from now onwards, we will show the complexity using big O notation. It is very important to know the rate of growth of big O notation. So these can be the complexity, like after finding the complexity, a particular algorithm may have a complexity of big O of log 2n. 2 is the base, though here it is looking like this, it is the base, 2 is the base, log base 2n, or another algorithm it is suppose big O of n cube. Now which algorithm you will consider to be better? If an algorithm is having this side, the more towards the left hand side, the big O notation is the better the algorithm. This complexity is better than this one. So if there are two algorithms which is having, one is having this complexity and another is having this complexity, then which one is better? This one is better. Okay. So this is the rate of growth of big O notation. I'll just tell you, this one is big O of log base 2n, big O of n, big O of n log base 2n, big O of n square, big O of n cube, and big O of 2 to the power n. This is having the worst complexity, this is having the least complexity. So this side, the towards left hand side, the complexity is better the algorithm. So in the next section, in the next video, we will be learning about the searching algorithms and sorting algorithms, and we will see there how to write down the complexity. Thank you.